We'll start in a couple of minutes. So the YouTube screen sees the full picture of the, not you. Yeah. All right, it's time to start. We'll be in section 6.1. That has to do with greatest common factors and factoring by grouping. So factoring, you might have heard that term before. Factoring is the reverse process of multiplying. Yesterday we discussed how to multiply polynomials, and factoring is doing that process in reverse. And you can always check your factoring by multiplying. First, we'll talk about the greatest common factor. The greatest common factor of two or more terms is the largest expression that is a factor of all of the terms. So we'll start with positive integers and find the greatest common factor. So what we'll do is we'll list the positive integer factors of each number. So I'll make a note of that up here. List the positive integer factors. And then after we've done that, we'll pick the factor that is the largest. The positive integer factors of 14. Well, 1 times 14 is 14, so 1 and 14. I'll put them in ascending order. 2 times 7. So the positive integers 1, 2, 7, and 14. Those are the positive integer factors of 14. We call them factors because they are involved when multiplying. to get a product of 14. The positive integer factors of 35, 1 times 35, 5 times 7. So from smallest to largest, 1, 5, 7, and 35 are the positive integer factors of 35. Then the largest factor that is in both lists is 7. So we would say that the greatest common factor of 14 and 35 is 7. So that's all there is to that. Some numbers have more factors than others. What are the positive integer factors of 13? One and 13, that's it. 13 is a prime number. So you might remember that if you have a positive integer that's a prime number, its only positive integer factors are 1 and itself. The positive integer factors of 21, 1 times 21, 3 times 7, so 1, 3, 7, and 21 are the positive integer factors of 21. And so the greatest common factor is just 1. So we would write the greatest common factor of 13 and 21 is just 1. Okay, let's list the positive integer factors of 24, and then after that, 60. So 24 has quite a few positive integer factors. 1 is a factor because 1 times 24. 2 is a factor. 2 times 12 is 24. 3 times 8, so 3 is a factor. 4 times 6. And then we list the other factors that matches with each of those 4. So 6, 8, 12, and 24. So those are the positive integer factors of 24. And the positive integer factors of 60. Well, that has even more positive integer factors than 24 does. So I guess we better get started. 1 times 60, so 1, 2 times 30, 3 times 10, 4 times 15, 5 times 12, 6 times 10, then what comes after 6? Well, we can check. 7 is not an integer factor of 60. 8 is not an integer factor of 60. 9 is not. So 10, yes. So now we're on the other side. 6 goes with 10 because 6 times 10 is 60. 12 goes with 5 because 5 times 12 is 60. 15 goes with 4 because 4 times 15 is 60. 20 goes with 3 times 20, so we're almost done. 2 times 30, so 30 is a factor. 1 times 60. So 60 has a lot of integer factors. What's the largest common factor, or the greatest common factor?
12.
Huh?
12.
Yeah, 12. So the greatest common factor of 24 and 60 is 12. So if you're pretty good at arithmetic, you'll learn how to identify the greatest common factor almost immediately, because you'll know when you compare 24 and 60, 12 is a factor of 24 and 12 is a factor of 60, and it turns out to be the greatest common factor. Okay, so for 17 and 51, what are the integer factors of 17?
1 and 17.
1 and 17. 17 is another prime number, so it only has two positive integer factors. And the positive integer factors of 51, well, I know 1 and 51. Then what? 3 is an integer factor. 3 goes into 51 17 times. So 1, 3, 17, and 51, those are the only positive integer factors of 51. And so the greatest common factor is 17. Greatest common factor of 17 and 51 is 17. So am I still mostly on the screen? Looks like we're doing okay. Hey, now let's look at some algebraic expressions and find the greatest common factor. So we want to find the greatest common factor of 45 times a to the second times b to the third and 18 times a to the fourth times b. So I'm not going to list all of the factors of each. It would take up too much space. So we'll just do it by comparing the numerical factors, 45 and 18. Well, I know that 9 times 5 is 45, and I know that 9 times 2 is 18. And it turns out that 9 is the greatest common factor of 45 and 18. So the greatest common factor of those two algebraic expressions will have a factor of 9. When we compare a to the second times a to the fourth, the greatest common factor is the one with the smallest exponent. A to the second is a factor of a to the second, because a to the second times 1 is a to the second. A to the second is a factor of a to the fourth, because a to the second times a to the second is a to the fourth. So a to the second will be part of the greatest common factor. And then the greatest common factor of b to the third time and b is just b. So 9a to the second b is the greatest common factor of those terms. Okay, the next pair, to find the greatest common factor of those two algebraic expressions, first we find the greatest common factor of the numerical factors, 21 and 28. What's the greatest common factor of 21 and 28?
7.
Yeah, 7. 7 times 3 is 21, and 7 times 4 is 28. So 7 is the greatest common factor of 21 and 28. Then we compare m to the fifth and m to the fourth. Well, m to the fifth is the same as m to the fourth times m. So m to the fourth is a factor of m to the fifth. And m to the fourth is a factor of itself. So when we compare m to the fifth with m to the fourth, we pick the one with the smallest exponent to be the greatest common factor. And then n to the second compared with n to the second. N to the second is the greatest common factor of itself. So that's the greatest common factor of those two terms. Okay, now we'll start factoring. And remember this. The first step in factoring is to factor out the greatest common factor of all of the terms. So that's a useful step to remember. So here, remember what factoring is. It's the reverse process of multiplying. So we have this expression, 28a to the fifth b to the third plus 24a to the third. We first want to identify the greatest common factor of both terms. So we do what we did above. Compare 28 and 24. The greatest common factor of 28 and 24 is 4. So the greatest common factor, the numerical part is 4. 4 times 7 is 28, and 4 times 6 is 24. Then we compare a to the fifth with a to the third. A to the third is a common factor of each. The term on the left has b to the third, but the term on the right doesn't have any factors of b. So the greatest common factor is 4a to the third. Okay, so when we factor out the greatest common factor of all of the terms, we're going to write the greatest common factor and then put that up against a set of parentheses. And then what we put inside the parentheses is determined by dividing each of those terms by the greatest common factor. So we'll do that down here. Let's divide 28 a to the fifth, b to the third by 4a to the third. 28 divided by 4 is 7. A to the fifth divided by a to the third is a to the second. And then b to the third divided by 1 is b to the third. Okay, so this is what we get when we divide 28 a to the fifth, b to the third by the greatest common factor. And now we'll divide the other term, 24a to the third, by the greatest common factor. So 24a to the third divided by 4a to the third. 24 divided by 4 is 6. A to the third divided by a to the third is 1. So we just get 6. Okay, so the idea is when we factor 28 a to the fifth, b to the third plus 24 a to the third, we factor out the greatest common factor, 4a to the third, and then we multiply 4a to the third times the quantity that we get by adding these two terms. So 7a to the second b to the third plus 6. So you can see why factoring is called the reverse process of multiplying. Okay. Yesterday we talked about how to multiply polynomials. So yesterday we did things like this: 4a to the third times the quantity 7a to the second b to the third plus 6. When you multiply that out, you get this polynomial on the left. Okay, so that's all there is to it. Factoring is a little more difficult than multiplying, but you can always check by multiplying that you factored correctly. Okay, let's try this one. This time we have 3 terms, and we want to factor it. So we're going to find the greatest common factor of all 3 terms first. So I'll do that up here, the greatest common factor of these 3 terms. So first we compare the numerical coefficients, the numerical factors. 25, 45, and 45. Well, 5 is a factor of 25, and it's also a factor of 45. And 5 is the greatest common factor of 25 and 45. Then we compare the variable parts. This first term on the left has m to the 5th. The term in the middle has m to the 3rd. And the term on the right has m, or just m to the 1st. So the greatest common factor of m to the 5th, m to the 3rd, and m is just m. And that's it. The term on the left doesn't have any factors of n, so 5m is the greatest common factor. Okay, so when we do the factoring, we're going to factor 5m out of all 3 terms. And we're going to multiply 5m times a quantity in parentheses. So how do we know what goes inside the parentheses? We can determine that if we divide each of those terms on the left by the greatest common factor. So I'll do that down here. If we divide 25m to the 5th by 5m, then 25 divided by 5 is 5. M to the 5th divided by m is how much? M to the 4th. So the first term inside the parentheses is 5m to the 4th. Remember another thing that I mentioned earlier, you can check your factoring by multiplying. So at each step in the process, you can check your answer. You can verify that 5m times 5m to the 4th is 25m to the 5th. So that checks out. Okay, then the next term inside the parentheses, we're going to be subtracting what we get when we divide 45m to the 3rd n by the greatest common factor of 5m. So just do it piece by piece. 45 divided by 5 is 9. m to the third divided by m is m to the second, and n divided by 1 is n. So the next term inside the parentheses is minus 9m to the second n. And you can verify just by looking that 5m times negative 9m squared n is negative 45m to the third n. Okay, then finally, to find the third term inside the parentheses, we're going to subtract what we get when we divide 45m n to the seventh by the greatest common factor of 5m. 45 divided by 5 is 9. M divided by m is 1. And then n to the seventh divided by 1 is n to the seventh. So the third and final term inside the parentheses is 9 times n to the seventh. Okay, then, if necessary, if you want to, verify the factoring by multiplying. Okay, we'll move on to the next page. It's going to be more of the same, mostly. And a little more room. Okay, factor the following expressions. In cases like this, where we have negative 42n to the third for a leading term, it's often easier if you factor out the negative of the greatest common factor. It's not required, but it might be something that, in my opinion, it does make the arithmetic simpler. We'll get to that in a minute. First, we want to identify the greatest common factor. So even though the coefficients are negative, we can still identify the greatest common factor as positive integers. So if we just compare 42 with 30, 6 is a common factor. 6 times 7 is 42, and 6 times 5 is 30. So 6 is a common factor. And then compare the variable parts, n to the third and n. N is a common factor. So one way to go about it is, as I mentioned, since the first term has a negative coefficient, I want to factor negative 6n out of each of the terms. With some practice, you can do a lot of this in your head. Negative 42 divided by negative 6 is positive 7. And n to the third divided by n is n to the second. So inside the parentheses, the first term is 7n to the second. And you can verify at each step that you're doing the right thing by multiplying. You can check negative 6n times 7n to the second is negative 42 times n to the third. So everything is checking out so far. Then the next term inside the parentheses, we're going to divide negative 30n by negative 6n. Negative 30 divided by negative 6 is positive 5. And n divided by n is 1. So that is the complete factorization in this case. And then you can verify by multiplying. Okay, the next one. First, find the greatest common factor. The greatest common factor of 14 and 44. Well, the factors of 14, or the positive integer factors of 14 are 1, 2, 7, and 14. The positive integer factors of 44 are 1, 2, 4, 11, 22, and 44. So the greatest common factor
2.
is 2 for the numerical factors. And then the greatest common factor of t to the 5th and t to the 4th is t to the 4th. So once again, since the leading term, the term on the left, has a negative coefficient, my preference is to factor out the negative of the greatest common factor. So negative 2 times t to the 4th multiplied by some quantity in the parentheses. And the first term in the parentheses is what we get when we divide, I'll go ahead and write this down, divide negative 14 t to the 5th by negative 2 t to the 4th. Negative 14 divided by negative 2 is 7. T to the 5th divided by t to the 4th is t to the 1st, or just t. So 7 times t. And then the next term is what we get when we divide negative 44 t to the 4th by the negative of the greatest common factor, negative 2 t to the 4th. So we're just going to get positive 22. Negative 44 divided by negative 2 is 22. T to the 4th divided by t to the 4th is 1. So it's just plus 22. Okay, the next stage in the process of factoring that we're going to discuss is to factor by grouping. Okay, most of the time when we factor by grouping, at least in this class, we're going to have 4 terms. And the factoring by grouping refers to factoring out the greatest common factor of the first 2 terms. And then in other words, we're grouping the first and second terms and factoring out the greatest common factor. Then after that, we'll group the third and fourth terms. If the middle operator is subtraction, like we have here, then what we're going to do is we're going to factor out the negative of the greatest common factor of the third and fourth terms. Then once we do that, we'll complete the factoring by factoring out a common binomial factor. So the first thing to do, though, remember the first step in factoring, factor out the greatest common factor of all of the terms. So in this case, the greatest common factor of all 4 terms is just 1. But if it were something other than 1, we would want to factor it out first, and then continue to factor by grouping. Okay, so when we factor by grouping, factor out the greatest common factor of the first two terms. So u to the second minus 9u. The greatest common factor is u. So when we factor u out, we'll get u times the quantity u minus 9. Then we group the third and fourth terms, but we include the middle operator of subtraction. So we're going to think of the third and fourth terms as negative 2u plus 18. And since the coefficient of u is negative 2, we want to factor negative 2 out, or the negative of the greatest common factor. The greatest common factor of 2u and 18 is 2. So we want to factor negative 2 out. And then what goes inside the parentheses can be determined by dividing the third and fourth terms by negative 2. Negative 2u divided by negative 2 is 1u, or u. 18 divided by negative 2 is negative 9, so we get the binomial u minus 9. So I'll back up a little bit. We're factoring a quadrinomial by grouping, and it's useful to know that not all quadrinomials, which means a polynomial with 4 terms, not all quadrinomials can be factored by grouping. When we can factor by grouping, it's a special case, but it's something that will come up frequently in this class from now on. Okay, so this is the first step in the factoring by grouping. And what we want to check, notice that the binomial u minus 9 appears in 2 places. And so what that verifies is that this quadrinomial can be factored by grouping. And then the final step is to factor the binomial u minus 9 out of each of those terms. So now we are in effect factoring the greatest common factor out of u times u minus 9 and 2 minus u times u minus 9. The greatest common factor is u minus 9. And then when we factor u minus 9 out, we're left with u minus 2. Okay, so that's the complete factorization, u minus 9 times u minus 2. So we're done. So let's use this example to check by multiplying, since we can always check our factoring by multiplying. Check by multiplying. So this is what we did, the kind of thing we did yesterday. So u times u is u to the second, and then minus u times 2, minus 2u, and then minus 9u, and then negative 9 times negative 2 is positive 18. So this is what we started with. I have the middle terms in opposite order, but it's equivalent to what we began with. Incidentally, though, note that this quadrinomial can be simplified to a trinomial because the two middle terms are like terms. So we could write this as the trinomial u to the second minus 11u plus 18. So what we're leading up to is factoring trinomials, which we'll talk about tomorrow. So if you begin with a trinomial, this one, u to the second minus 11u plus 18, and then find its factors, we'll end up with two binomial factors, u minus 9 times u minus 2. But in the factoring of trinomials process, the intermediate step is going to involve factoring by grouping. So that's why we're discussing how to factor by grouping, so that when we get to factoring trinomials, we'll know how to take it from that step. Okay, so more of the same. Here's another quadrinomial. Factor by grouping. So out of the first two terms, what can we factor out? What's the greatest common factor of a times b and 2b? The greatest common factor is b. And when we factor b out of the first two terms, we're left with the binomial a minus 2. The middle operator is subtraction. So if the middle operator is subtraction, when we group the third and fourth terms, we want to factor out the negative of the greatest common factor. So the greatest common factor of a and 2 is 1. So we're going to factor out negative 1. So we'll write minus 1. And then when we factor negative 1 out of negative a plus 2, negative a divided by negative 1 is a. And 2 divided by negative 1 is negative 2. So we write a minus 2. And then just get into the habit of visually checking. Negative 1 times a is equivalent to minus a, and negative 1 times negative 2 is equivalent to adding 2. So everything checks out. The two binomials match again. The a minus 2 appears in both places. And so now we just factor a minus 2 out. And the other factor that stays behind is b minus 1. Okay, then you can check by multiplying. Let's move on to the next one. Q to the second minus 2q plus 6q minus 12. We're factoring by grouping. Out of the first two terms, factor out the greatest common factor. So if you're online, type in the greatest common factor of q to the second minus 2q. So I got an answer. Yeah, I'm going to write capital Q instead of lowercase q. So we factor q out, and the binomial that stays behind is q minus 2. And then verify by multiplying. So you can tell just by looking that we're on the right track. Okay, now we have a middle operator of addition. So it's easier when the middle operator is addition. We're just going to factor out the greatest common factor of the third and fourth terms. So 6q minus 12. What's the greatest common factor of 6q and 12? Okay, so 6 is the greatest common factor. And then when we factor 6 out, 6q divided by 6 is q. Negative 12 divided by 6 is negative 2, so we write minus 2. And the binomials match. Q minus 2 appears in both places. So that means we can continue the factoring. We factor out q minus 2, and the other factor is q plus 6. So that is the complete factorization. Okay, the next one, well, this one is a typographical error. The 3x should be 3 times capital X. But we will proceed. So we'll factor by grouping out of the first two terms, x squared minus 6x. The greatest common factor is x. And when we factor x out, we're left with x minus 6. The middle operator is addition again, so that's the easier situation. So we just factor out the greatest common factor of the third and fourth terms, 3x minus 18. The greatest common factor is 3. And when we factor 3 out of 3x minus 18, we're left with x minus 6. And then we factor x minus 6 out, and the other factor is x plus 3. Okay, we have about 4 minutes left, so we'll just practice more. So factor the following expressions. So when faced with directions like that, factor the following expressions. What's the first thing that you think about? Okay, here's a polynomial and you're supposed to factor it. So the first thing that comes to mind?
Greatest common factor.
Yeah, the first step in factoring is factor out the greatest common factor first. And then my advice is if the leading coefficient is negative, like it is in this one, it's not required, but in my opinion, it's easier if you factor the negative of the greatest common factor out. Okay, so let's first find the greatest common factor. When we just think of positive 32 and 14, what's the greatest common factor of 32 and 14? 2. Yeah, the integer factors of 14 are just 1, 2, 7, and 14. And the integer factors of 32 are 1, 2, 4, 8, 16, and 32. So the greatest common factor is 2. Then we compare the variable parts, m to the fourth and m, the greatest common factor is m, then n to the second compared with n to the third, the greatest common factor is n to the second. Okay, so I'm going to factor negative 2m n to the second out. And then you always have to be careful with the signs. So the first term inside the parentheses is what we get when we divide negative 32 m to the fourth n to the second by negative 2 m n to the second. So just do it piece by piece. Negative 32 divided by negative 2 is positive 16. M to the fourth divided by m is m to the third. And n to the second divided by n to the second is 1. So the first term in the parentheses is 6m to the third. Okay, then the next one, the next term in the parentheses is what we get when we divide 14m n to the third by negative 2m n to the second. 14 divided by negative 2 is negative 7. M divided by m is 1. And n to the third divided by n to the second is n. So we just have minus 7n. Okay, so that's just about all the time we have. The rest of the problems are like the ones that we've already done. So you should be able to finish the rest of those if you can go back and look at the notes on the other ones. Okay, so I guess that's all for today.